I'll be explaining how to find the inverse of 3 by 3 matrix. If A equals to this 3 by 3 matrix, find A inverse. Now, before I proceed, I would like you to know that the formula for finding the inverse of any matrix equals to 1 over the determinant of A multiplied by the adjoint of A. This is the same thing as saying adjoint. Now, what is the formula for calculating the adjoint? The adjoint of A is the same thing as saying the cofactor of A transpose. So you need to calculate the cofactor, then you transpose it. For a 2 by 2 matrix, it is very easy, but for 3 by 3 matrix, it is not. Now, let's start. So the first thing we have to do is to calculate the determinant of A. And to calculate the determinant of A, here you come up here, you ascribe some sign. And what are the signs? Here you call this plus, minus, plus. I mean on the first row. Now, to calculate the determinant of A, you pick the first element from this matrix, which is 1. Okay? Multiplying this by what? Don't forget the sign is positive. Multiplying it by a matrix. What kind of matrix it is? It is a 2 by 2 matrix. And how do you determine the matrix? Now, this is the method. Just look at this row of 1. The row of 1, cancel it out. And cancel out the column of 1. So look at it. This column of 1 is being cancelled and the row of 1 is also cancelled. So we are left with 1, 2, 2, 1. So we are left with 1, 2, 2, 1. So this is what I did. I cancel out the row of 1 and I cancel out the column of 1. That is what I did. Okay? Now, the same thing will be done. The same thing will be done for the next column. I mean, for the next element. The next element is negative 2, which is this. For negative 2, let's cancel out the row of negative 2. Cancel out the row and cancel out, excuse me please. We cancel out the row of that and also you cancel out the column. So we are left with 2, 2, 2, 1. So we are left with 2, 2, 2, 1. And the same thing will be done for the last element, which is positive 2. So for this, you cancel out the row. This is the row for positive 2 and this is the column for positive 2. So here you are left with 2, 1, 2, 2, which is this matrix. So here we have 2, 1, 2, 2. Don't forget that this sign is determinant sign. And to find the determinant of a 2 by 2 matrix, you can check my video from the playlist. You will see how you can find the determinant of 2 by 2 matrix. But I'm going to explain it again here. So here we have 1 multiplied by. To find it, here you have 1 times 1. So you multiply this diagonal minus this diagonal, which is 1 times 1, 1, minus 2 times 2, which is 4. So the same thing for the next one, which is negative 2. 2 times 1 is 2, minus 2 times 2, which is 4, plus 2. 2 times 2 is 4, minus 2 times 1, which is 2. Now here, we have this to be 1, -3 multiplying minus 2. 2 minus 4 is minus 2. Plus 2. 4 minus 2 is 2. So here we have -3. Minus times minus is positive 4 plus 4. So the determinant of A equals to 5. The determinant of A equals to 5. And looking at the next is to calculate the cofactor of the 3 by 3 matrix. We've gotten the determinant of A to be what? To be 5. Then how do we calculate the cofactor of A? We're going to use the same approach we used, but there's something different in that. Now, for the cofactor of A, this is row 1, column 1, row 2, column 2. Let me just put something here. This is a 3 by 3 matrix. This is A11. This is A12, A13. That means the first row and each of the columns. So here we have A21, A22, A23. And here we have A31, that is the third row, A32, and A33. This makes a 3 by 3 matrix. Now, we're going to calculate each of them one by one. This is how to calculate the cofactor. So we need each of the elements. So the same approach will be used. Now, for the first one, but the only difference between this and determinant is that the coefficient will not be multiplied. But before you start, there's a need for you to do this. Plus, minus, plus, minus, plus, minus, plus, minus, plus. You need to ascribe these signs because we're going to need the signs. Now, let's start. So we pick up the first line of 1. So after picking it, I'm going to cancel it out. So we want to pick 1 now. Let's cancel out 1. So what do? You close the row and you close the column. And here we have 1, 2, 2, 1. So this is what you have. After you close the row and you close the column, so this is what you have. Okay? And what is that? 1 times 1, we have 1, minus 2 times 2, which is 4. So the first one is going to give you -3. And here we have A12. This is A12. Now, looking at this, close the column and close the row. You'll be left with 2, 2, 2, 1. So 2 multiplying 1, we have 2. Minus 2 multiplying 2, we have 4. So this is going to give us -2. But recall, we are having the negative sign here. So we have the negative sign minus, and this gives 2. And the next one here we have A13. That is the last one here. Now, for this, here we have that this row and this column and this row will be crossed out. So we have 2, 1, 2, 2. 2, 1, 2, 2. So here we have 2 times 2, which is what? 4. 2 times 1 minus 2, which is 2. So if you look at the sign here, it's positive. So this will also be positive. And the next one here is to move to the second row, which is this. And here we have A21, that is second row, first column. Here we have, if you cancel out this row and you cancel out this column, you have 2, 2, 1, 2, 1. 2, 2, 2, 1. Don't forget that the sign here is negative. So here we have the negative sign outside. So here we have the negative 2 times 2. 2 times 1, 2. Minus 2 times 2, 4. So here we have negative, negative 2, which gives 2. And the next one we have A22. So using the same approach for A22, which is this, we have positive outside. If you cross out the rows and the column, we have 1, 2, 2, 1, which is 1 minus 4, which is negative 3. And also if you have A23, for A23, which is this, if you cross out this, the line here, we have negative outside. If you cross out this row and this column, we have 1, 2, 2, 2, 1, 2, 2, 2, which is negative 1 times 2 is 2, minus 2 times 2, which is 4, which is 2. Now, if you apply the same method all through, so if you apply the same method here, you have your A31 to be 2, A32 to be 2, and A33 to be negative 3. So our cofactor of A is going to be our A11, which is negative 3, our A12, look at it, this is the matrix I'm following, our A12, which is 2, our A13 is also 2, and the next line we have A21, which is 2, negative 3, 2, and the last one we're going to have 2, 2, negative 3. This is a symmetric matrix. And don't forget, I told you that the adjoint of a matrix, of matrix A, equals to the transpose of cofactor of A. So we find the transpose. If you find the transpose of this, so your adjoint is going to be the transpose. And what do we call a transpose? Look up here. If you have 2, 3, 4, 5. Transpose means you want to change rows into column. Row to column. That is the meaning of transpose. So this is the first row. You change it to column, which is 2, 3. This is the second row. You change it into column, 4, 5. Changing row into column is called transpose. But looking at this, this is a symmetric matrix. A symmetric matrix means that the row, if you change the row back to the column, you still have the same matrix. That is called a symmetric matrix. You can check my playlist. You see one of the videos I made into about the foundation of matrix. You will see everything there. So now, if you do this, this is a symmetric matrix. You still get the same matrix. So your adjoint is still going to be the same thing as your cofactor of this matrix. But in some cases, it can change. Yes, in some cases, it can change. But for this matrix, you have the same thing. So you have 2, 2, negative 3. And lastly, our A inverse. Let me put this. Our A inverse is going to be 1 over determinant. This is our A inverse, which is going to be, our determinant is 5. So 1 over 5, which is the determinant, times the adjoint of the matrix, minus 3, 2, 2, 2, minus 3, 2, 2, 2, minus 3. You can leave the answer like this, or you can simplify further by saying minus 3 over 5, 2 over 5, 2 over 5, 2 over 5, minus 3 over 5, 2 over 5. By dividing, 1 over 5 is going to be your, so 1 over 5 is going to be a scalar. 2 over 5 and minus 3 over 5. So this is going to be your A inverse. Thank you very much for watching. See you next time. Please don't forget to subscribe.